Question 16. Three identical resistors can be connected together in four different configurations. The resistance of two of these configurations is 7.5 ohms and 15.0 ohms. What is the resistance of each individual resistor? This problem tests our understanding of resistors in series and parallel, and how combinations affect total resistance. What do we know? We know that identical resistors all have the same resistance value. Different combinations of resistors lead to different total resistances. For n identical resistors in series, the total resistance is simply N times R. For n identical resistors in parallel, the total resistance becomes R divided by N. In mixed arrangements, the total resistance lies between the extremes given by all series and all parallel combinations. Now, let's work through the solution. We start by trying the smaller total resistance, 7.5 ohms, as if all three resistors were in parallel. For three resistors in parallel, the total resistance is R divided by 3, so R over 3 equals 7.5. Solving this gives R equals 22.5 ohms, which is not one of the options, so this arrangement does not work. Next, we try a combination of two resistors in parallel and one in series. The two in parallel have a resistance of R over 2. Adding the third in series gives a total resistance of R plus R over 2 equals 7.5. Simplifying, 3R over 2 equals 7.5. Solving for R, we find R equals 5 ohms. Now we need to check if their resistors, all identical, can possibly give an effective resistance of 15 ohm in any combination, as we have not determined that they can give an effective 7.5 ohm for a certain combination. To check, let's put all three resistors in series. The total resistance would be 3 times 5 ohms, which equals 15 ohms. So all three of 5 ohm resistance fits both cases. This is our final answer. What did we do? We tested possible combinations of three identical resistors, starting with parallel and series arrangements. By checking the totals against the given resistances of 7.5 and 15 ohms, we determined that each resistor has a resistance of 5 ohms. Finally, here are the key points to remember. Identical resistors have the same resistance value, so any combination depends only on how they are connected. For n of them in series, their total resistance is NR. For n of them in parallel, their total resistance is R over N. All series and all parallel configurations give the maximum and minimum possible total resistance, respectively. Mixed combinations, such as 2 in parallel and 1 in series, always produce total resistances between these extremes.